Okay, we are moving on to lesson 2.1, finding square roots and comparing real numbers. To start off, we want to talk about what a square root is. A square root, when you are taking the square root of something, you are trying to find what two numbers multiply to the number inside. For example, the square root of 4 is 2. Radicand versus the radical. Whenever you have the square root of something, let's say the square root of 8, the radicand is what's inside. So 8 is the radicand. The radical is that symbol that we use to represent a square root. Perfect squares are any numbers that have two numbers that perfectly multiply to that number. So 4, 9, 16, 25, 36, and the list goes on and on and on. Now we're going to talk about different types of numbers. We are going to start off with integers. Integers are all numbers, -1, -2, -3, includes 0 and includes the positives. So the negatives, the positives, and the zeros. Whole numbers are just 0, 1, 2, 3, and so on. Does not include the negatives. Rational numbers are any numbers that can be written as a fraction. So 2 can be written as a fraction. 1/2 can be written as a fraction. 2 can be written as the fraction 2/1. Okay. Irrational numbers are the opposite of rational. Any numbers that cannot be a fraction. Examples of these include pi, the square root of 2, and many others. Real numbers are just all numbers that are not imaginary. Okay, so 1.22222, pi is a real number, the square root of 2 is a real number, 2 is a real number, 1/2 is a real number, so basically any number that's not imaginary. And one thing that we did not cover in this list over here is our natural numbers. Our natural numbers only include 1, 2, 3, 4, all the way up into infinity, does not include the zeros, and it also does not include the negatives. If we look at this chart right here, the natural numbers, 1, 2, 3. The whole numbers include all the natural numbers, and then we add in 0, and those are our whole numbers. The integers include the whole numbers and the natural numbers, but then we also can add in the negatives. And then the rationals include everything that we have here, but also fractions as well. And then our irrational numbers are off to the side here. Finding square roots, evaluating square roots. We know that the square root of 36, what two numbers multiply to 36? 6 and 6. We have a plus or minus here in front, so our answer is going to be plus or minus 6. Now, why is it plus or minus 6? Because 6 times 6 is 36, and -6 times -6 is also 36. For this one, the square root of 49, we know 7 times 7 equals 49. And the negative square root of 9, well, the square root of 9 is 3, so therefore the negative square root of 9 is -3. When you are estimating square roots that are not perfect squares, your goal is to think about what two perfect squares is the number in between. So if we look at the square root of 12, we know that 9 is a perfect square and 16 is a perfect square. Well, what is the square root of 9? The square root of 9 is 3. And what is the square root of 16? The square root of 16 is 4. So therefore, we know that the square root of 12 has to be between 3 and 4. If we look, 12 is closer to 9 than it is to 16, so it's going to be a little bit closer to the 3. So when we estimate it, it's going to probably be about 3.4 or something. Okay, it's taking your best estimated guess. Square root of 35, what two perfect squares have 35 in between them? In this case, 25 and 36. Well, what's the square root of 25? 5. What's the square root of 36? 6. Well, 35 is closer to 36, so therefore it's going to be closer to 6 than to 5, so probably somewhere in the upper tenths of 5. Moving on to the next thing. State if the following numbers are rational or irrational, and then put them in order from least to greatest using your best estimate. Well, we know the square root of 4 is 2. That's going to be a rational number because it can be written as a fraction. 3/5 is already a fraction, so that is also going to be rational. The square root of 10. Anything that is not a perfect square is going to be irrational because it's going to have a decimal that goes on forever and ever and ever with no repetition. Then we know that 2 squared is 4. In which case, if 2 squared is 4, we know that that is also going to be a rational number. Now putting them in order, let's estimate here and here. 3/5 is 0.6, and the square root of 10 is going to be about 3 point something, maybe 3.1. Okay, so then we're going to put these in order. The lowest number is 3/5, then the square root of 4, then the square root of 10, then 2 squared. Okay, the last thing we are going to cover, actually we're going to go ahead and go back to the page we were just on, filling in this chart here. Remember what each of these numbers are. A real number is pretty much any number. A rational number can be written as a fraction. An irrational number cannot be a fraction. An integer is -2, -1, 0, 1, 2, all those numbers, backwards and forwards. And a whole number is just 0, 1, 2, does not include the negative. So when we're going through this, we are going to have to look at the square root of 144, identify what that square root of 144 is, and then label each of these. Well, the square root of 144 is 12. Is 12 a real number? Yes, pretty much all numbers are real numbers. Is 12 a rational number? Can 12 be written as a fraction? Well, that fraction is going to look like 12 over 1, so yes. If it's a rational number, it's not going to be an irrational number. Is 12 an integer? Well, it will be an integer because it exists in those positive whole numbers. And is it a whole number? Yes, it is a whole number. Moving on to negative square root of 49. What is the square root of 49? It's 7, so this is going to be -7. Is it a real number? Yes, all numbers are real numbers. Is it a rational number? Can it be written as a fraction? It can be written as -7 over 1, so yes. Is it an irrational number? No, because it is a rational number. It can be written as a fraction. Is it an integer? Well, if we look, our integers include those negative numbers, so yes, it is an integer. But is it a whole number? Our whole numbers only include those positive numbers, 0, 1, 2, 3, 4, so therefore, no, -7 is not a whole number. Last one, the square root of 32. If you were to take your calculator and type in the square root of 32, you would get 5.6568, and then a whole bunch more numbers. Keeps going on forever and ever and ever. Well, is this a real number? Yes, it's always going to be a real number. Is it a rational number? Can this number be written as a fraction? It cannot be written as a fraction because we do not know what the rest of those decimals are going to be. Is it an irrational number? Yes, because it cannot be written as a fraction. Is it an integer? No, because it's a decimal. Is it a whole number? No. Last thing we are going to cover here is finding cubed roots. Cubed roots, any number multiplied 3 times to get to the number in the cubed root. A cubed root will always have a little 3 in here. The cubed root of 125, well, what 3 numbers multiply to 125? It has to be the same number. 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. That is where we are going to end today.